Hello there, Gamal Basalu here. Today I'll be explaining about a Java program which uses a doubly linked list data structure that serves as our database for our freshman applicant records. So in this Java program, I created three Java classes which are the record.java that has our main method and freshman applicant.java which contains the fields and infos of a freshman applicant. And third one is the doubly linked list.java, which is the Java class which is responsible for creating a doubly linked list. Once this constructor is being called, a list will be created. And here we have all of the methods that we can use to insert, delete, and other stuff into our list. So here in the record class, we declared a constructor which calls the doubly linked list constructor to create a list. So here, as you can see, before the main method starts, we declared a record r1 to create a new list which calls the record constructor. Therefore, before the main method starts, we already created a list for the record. So to start with the main method, the user can input 8 different tasks. So to start with the adding the freshman applicant, so I have here an add underscore record method which is intended to add a freshman record. So as you can see, I have an if statement which is only to prompt the user that the list is still empty and he needs to input something so that he can insert some record. So here in the second if statement, this if statement is only used for the initialization of the static fields of the freshman applicants, which is the total items and the percentage of each subject. And here in the second in the third if statement, which has a condition of check applicant number, this if statement is only intended for the first insertion of the applicant. As you can see, in the second if statement, I already inserted an element into our list, so therefore it is not already empty. So what this condition does is that it checks the application number. If it's still a null field, then this will be executed once. Therefore, you can now add some applicant number, name, school score, and its grades. And this if statement, the third if statement, will only be executed once. Next, we have an else if statement, which is basically executed right after the first insertion. And this first else if statement is intended only for the case where there is only one record in our list, and it has a condition that the list should be not empty anymore, and a compare number is called. This is a Boolean method that returns a true value when the first applicant number in the list is greater than the to be added applicant number of the new record. Then the to be added applicant record should be inserted at the first position of our list. In the second else if statement, this is only intended for the deletion part, where the user wanted to delete the first position of our list, the very first node. And the reason for this is that I did not created a head node, therefore I cannot assign a null value all throughout the fields of the first node in the list. Therefore, I just assign a 0 value for the integer field and a null value for the non-integer field of the first node. So lastly, we have an else statement, which is mostly to be executed right after the first insertion made by the user. So this line, which is to print out something, is only intended for the debugging purposes, which I will show you later once we run this record.java. And here we have declared variable p, integer variable, to be assigned with the return value of the scanf method, which returns an integer value. And this method is located at the Doubly linked list.java. So here in its implementation, we have declared current variable to refer the object freshman applicant to be assigned with the first node, which is not anymore null. As you can see here, we declared first as null, but as I said earlier, the else statement, which is only intended once, will be executed right after the first insertion. Therefore, the first node is not anymore null. So we have declared an integer I0 to become our position pointer, and here we have also a while loop to scan all the nodes and only stop when it reaches the node that has the right pointer, which has a null value. So this if statement has a condition of the applicant number, which is inside already in our list, is greater than the to be added applicant number, then this while loop will break or stops, and therefore the value of the incremented I will be returned. So here, as we already gathered the value for the variable p, then we will call the insert at method, which is located here in the Doubly linked list, which has a parameter of fields, score, name, applicant number, grade, English grade, and also the most important part is the where's that the integer position. Where is here position? So this is being passed already, and as you can see here, the record.java, in the add record, you can see the position of the integer p is also what do you call this, aligned with what is the position of the applicant number. So here it is being located here right after the English score, and this one is the p variable is assigned to the list size, which is a method for counting the size of our list. And here this will be also intended for the debugging purposes. This one is only for the user wanted to add more record. So here, the second test of this program. Here we have a first if statement, which is intended to prompt the user that he or she cannot delete an element in our list which is empty. Therefore, he or she needs to insert first an element before he or she can delete. So here, as long as the user has already input the applicant number, then p variable integer will be assigned to the return value of the find up number with method that has a parameter of applicant number. And what does that find up number method does is that it scans the it has a while loop that scans the whole list, and it increments for every iteration. It increments the I the I integer. And once this if statement is executed by its condition, which the application number that is being input from by the user has matched with the applicant number of one of the node, then this while loop will instantly breaks and returns the value of the incremented I. Then back to the delete record. So here we have assigned a value of the least return value of the least sized method. As I said earlier, this least size method only counts the size of our list, and that will be assigned to the sized variable. So here we have an if statement, which is only intended for the case where there is only one node in the list that the user wanted to delete, and we cannot perform a delete at method here because there is only one node. So what does that only node delete does? So let's try to find out here. So here the current variable is declared to refer the freshman applicant object or class, and is assigned to the first node of the DLL R1 list. So as I said earlier, in the add record method, I have an if statement there where it searches for the applicant number which has a string value of 0. So this is the reason why I created that statement, because some of the fields are being assigned to 0 for the integer and null for some string, and 0 for the applicant number, 0 string value. So back to the delete record. So here in the next statements, which are the else if and else, so this else if statement is only intended for the case where there's only two nodes left in the DLL list, and the position that is being matched with the applicant number that is being input by the user is the position 2. Therefore, we cannot perform a delete add method here because the delete add will need 3 or more nodes in the list. So therefore, we can only perform a delete and method here. So what does this delete and record does? So let's find out. So here we have a temp variable that is being declared to refer the freshman applicant object that is being assigned to the first node of the DLLR1 list. Then it has a while loop that scans from the first node until to the second to the last. So it has temp will be assigned to the right pointer, and at the end of this while loop iterations, the temp variable will be equal to the second to the last node of the list. Then once this while loop is ended, the right pointer of the temp, which is the second to the last node, will be assigned to the right pointer of the last node, which is null. Therefore, the right pointer of the second to the last will be null, and then the last node is being deleted. Back to the delete record. The next else if statement is intended for where the position of this else if statement is intended when deleting an element, where the position of the element that is going to be deleted is at the last position. As you can see, the condition is the position is equal to the size of the list. Therefore, the position of the to be deleted node is at the end of the list. Then we can perform a delete and method, and these lines are only intended for the debugging purposes. So In the else statement, we have here calling the method of the delete at, and which has a parameter, integer parameter, which is passed, and this is the position pointer of to be deleted position. So let's see what does delete at. So basically it has a int parameter. So temp is assigned to the freshman applicant. Temp is referred to the freshman applicant object, and then it is assigned to the first node of the DLLR1 list, and it has a for loop, which at the end of the for loop, temp will be assigned to the value of the node, which is pointed by the position. So let's say we have the size of the list is 3, and the middle is the pointed one. Then the middle will be the one that is being assigned to this temp, and this temp, the right pointer of that node will be assigned to the right pointer of the next node right after the temp node. So that's how it does. So now we have arrived to the third task of this program, which is to display all the records. So this is just basically going to display all the fields, all the records of each node or each element in the list. So first, the current variable is declared to refer the object freshman applicant to be assigned as the first node of the DLLR1 list. So this current is the first node. So this if statement is only to prompt the user that if the list is still empty, then there's no records yet, and the only thing that he or she should do is to answer yes for the exception of this block of code. So as long as there's already a record, the while loop is intended to scan the first node until the last node of the list, and it only stops when the current reaches the last node. The current is the last node, and its right pointer is equal to null. Then this while loop will not be executed anymore. Then that's how simply the third task is all about. And here we have the fifth task of this program, which is the highest overall, to display the highest grade of all the records. So first if statement is to prompt the user that the program cannot display a record unless he tries or she tries to input first a record into the list. And here we have declared a variable POS to be considered as our position, and I to be the integer that will be incremented. And this if statement is used only if there is only one node in the list and the user wanted to display the highest overall grade. Then if there's more than if basically there's more than one node in the list, this will be executed. Then current variable is declared to refer the freshman applicant object that is assigned to the value of the first node of the DLLR1 list. Then we have declared the lowest grade, because as we know, lowest in our grading system is the highest grade. Therefore I name it as the lowest, and it is assigned to the very first node its overall grade. Then we have a while loop which ends until only the last node of the list, which current that right is that equal to null condition. So here we have an if statement. Once the lowest grade is higher than the next overall grade node, then lowest will be assigned to that overall grade. Then the position will be equal to the I and added by 1. Then I is incremented and currented, right? Then as long as the process is done until the while loop is terminated and it reaches the last node of the list, and the position will be used for a parameter passing for the loop for method. This method is just simply not likely similar with the display all method, but what they do is just to look and display look for here. So what's the difference is that it has only a for loop and not a while loop. So current variable is declared to refer the freshman applicant that is assigned to the first node of the DLLR1 list. So for loop, so this current will be at the end of this for loop. This current will have the value of the node which has the highest overall grade, which is inside this condition. So that would be for the highest overall grade. So here in the next task, which is the lowest, the opposite of the highest overall grade. So this is just the same with the highest overall grade. I just copy paste it, and what I have changed are these variables, which from we're in the lowest, then I change it to highest, and the condition I inverted the operator. I mean the boolean operator, and all are just the same with the highest but with opposite operations. So that will be for the lowest overall. It's just simply closely the same with the highest overall because it's just the opposite one. And here in the highest, which is this could be the sixth task, which is to show the highest science score, I mean science grade. So it is just all the same with the highest overall, but the only thing that is being changed is that the science grade, because in the science overall it was the overall underscore grade. Then yeah, the difference is this focuses on the science, I mean subjects only, and also the same with the math and English. They're just all the same, and I just copy paste it from the highest overall and just change it. So let's try to check if that's good. In the math, all the same. So that's it for the explaining all the task of this program. So the next one later will be the testing of the program. So for now we'll be testing our program. So let's add a freshman applicant. Let's say freshman applicant 2 GAMS Puerto. Science total, let's say 30, and percentage 30, 40, 30, 100, and with a score of let's say GAMS has the highest science score. Then math score, he got 15 only. English, let's say 10. Then let's add another one. Let's say applicant number 6. Let's say Basalio. High school Puerto. Score, he only got 15. Let's say 13 on science. He got the highest on math and English score with only, let's say 15. And let's add another one for the third one. Let's say applicant number 4, and name is let's say Hans, high school Puerto. science score. Let's say he got only 10. Math score, let's say 10, and he got perfect on English. And let's try to check if the records are in ascending order. So let's see, applicant number 6 at the last node, applicant number 4 at the second, and applicant number 2 at the first node. So let's try to check who got the highest overall. 4.20, 4.11, and 4.78. So basically this should be the first this should be the highest overall grade, applicant number 4. So let's try then. Let's display highest grade. Oh no. Oh, applicant number 6 has 3.58, sorry. And let's try to check if we get the lowest. It's applicant number 2 with 4.2. Was it really correct? Let's try to check. 3.58 highest, number 6. 4.11, number 4. And number 2 with 4.20. That's correct. Let's try to check who got the highest in science. It was applicant number 2 with a science score of 22 and a grade of 2.78. Let's try to check that. Applicant number 2, 22, 2.78, 5.44 only, and that's correct. Let's try to check with the highest math score, and it was applicant number 6 with a grade of 2.11. Let's see, number 6, 2.11, and number 4 only got 5.44, and applicant number 2 got 4.33. That's correct. Let's try to check the last one, which is the English, and 8. And basically it was applicant number 4, and that's absolutely correct. And then let's try to delete applicant record. Let's say applicant 6. It was at the position 3, and let's delete another one, which is at position 4. No, it was at position applicant number 4. Let's try to delete applicant number 4, applicant record 4, and it was at the position 2. So I think that would be all, and thank you for watching.